This is a quick little video about the order of operations and what is the best way to remember the order of operations. Now, some teachers come up with this acronym of PEMDAS, and I'm here to tell you that I really don't want you to think of it that way, and I'll tell you what to think about it in a second. So let's take a look here at what these letters, this acronym stands for. P is for parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. Now, I want to think about it a little bit differently in the way we would in mathematics. There really are 3 stages here that are involved. And when we look at stage 1 talks about the grouping symbols, the parentheses and the exponents, and grouping them in a certain way for us to evaluate first. So we always need to evaluate the group first. Our second stage is called multiplication and division, and we refer to those as the higher operations. The reason we refer to them as higher operations is because the numbers will either increase or decrease at a much steeper rate. And then stage 3, which is addition and subtraction, and these are the lower operations because numbers will increase and decrease, but at a much lower rate. So let's take a look at some problems and apply this. Now, the reason that we do it in stages is that you can do anything within the stage as long as you're working left to right. So that's something to think about, and we'll see it in our practice right now. So here we have a problem, 15 plus 6 divided by 3. Now, according to our order of operations, we're going to do, there is no stage 1 here, so we're going to go straight to stage 2 because we have it here in division. 6 divided by 3 is 2. So if I bring the rest of the problem down, now I am left with a stage 3 problem, and I'm left with 15 plus 2, which is just 17. We're going to try another problem here, which is 9 divided by 3 times 2. And we notice that both in this division and in this multiplication, these are both stage 2 operations. So like I mentioned before, when we have operations that are from the same stage, we're going to go from left to right, just like we read the problem. So we're going to start at the beginning of it and continue. So with that in mind, we're going to do 9 divided by 3 first. So that'll give us a 3. And then 3 times 2, which is 6. So that helps us all to end up in the exact location we want to be. Let's take a look at something when we're evaluating, and now we have some exponents. So let's evaluate x plus 3x to the 4th power when x equals 2. So we're going to take this value of 2, and we're going to plug it in to these different places and replace. So we're going to replace this x with a 2. We're going to replace this x here also with a 2, but it's going to the 4th power. So we're going to take a look at this and see where we're going. So we know that we've got some things going on in our stages. So let's take it by stages. So stage 1 says we need to work with those exponents first. So that exponent 2 times 2 times 2 times 2, I have 4 2's. 2 times 2 is 4, and 4 times 4 is 16. So we're going to replace this 2 to the 4th power with the number 16 and rewrite this. So we've done with stage 1. Now we do have a stage 2 here kind of hiding. Some people might see the parentheses and still think it's stage 1, but we know that sometimes between numbers here, the numbers 3 and 16, that parentheses right there represents multiplication. So we're going to multiply 16 times 3 from stage 2, which will give us 48. And now we're down to a normal stage 3 problem, 2 plus 48, which is 50. So hopefully that makes a little bit of sense there. I've got another problem hiding in here somewhere. There it is. I'm going to move it down so that we have some more room. Here I have 2 to the 3rd power plus 5 minus 2. So what we'll do this time is, again, working with that stage 1 right here. This is 2 times 2 times 2. And so 2 times 2 is 4, and 4 times 2 is 8. So we're going to replace this 2 to the 3rd power with an 8 and bring everything else down. So we have 8 plus 5 minus 2. We have no stage 2 operations here, but we have 2 stage 3 operations. And so we're always going to go from that left to the right. So we're going to start here, 8 plus 5, which is 13, and 13 minus 2, which is 11. So that kind of helps us with that. But let's say it's something that's even more involved than these. Here's a great last problem for us to look at from order of operations. This is saying 13 minus 4 is divided by 18 minus 4 to the second power plus 1. Well, this bar right here, this division bar, kind of helps us with a grouping. So let's see if we can come up with the numbers in a better way so that we can group them effectively. So let's start with the top first. I have 13 minus 4. Well, 13 minus 4 we know is 9, so we'll leave that there for a second. And now what we'll do is we'll go down and look at the bottom. We're going to keep that 18. We're going to say minus, and here I have 4 to the second power. We have to remember that 4 to the second power is 4 times 4, which is 16. So let's replace this 4 to the second power with a 16 and adding the 1. Once again, these are both from stage 3, subtraction and addition, but we're always going to start from the left and work our way to the right. So 18 minus 16 is 2, and 2 plus 1 is equal to 3. So this whole statement underneath here, this expression, 18 minus 4 to the second power plus 1, really reduces down to 3. So now when I look at this problem, and remember that a fraction bar means division, now I have 9 divided by 3. So 9 divided by 3 is going to give me 3. If I wrote this horizontally, and I'm going to do that really quick here to kind of show you where that grouping symbols might have come into play, I could have said 13 minus 4 divided by, and then put the other grouping here, 18 minus 4 squared plus 1. We have the grouping symbols in a way, and we did that by separating it as a fraction, but we can see that there's another way that this problem can be stated. Now, one more thing I want to look at before we leave is just some words and discuss some words with you for these different operations. So, when we're looking like at the word add, there are multiple words that will also mean add. One word would be sum, plus, greater than, increase, and total. When we look at words that might mean subtract, other words might be minus, difference, less than, decrease, take away, or deduct. We can look at some words for multiply. We see these words, we know they're talking about multiplication of, times, product, and by. And lastly, for divide, we don't have too many words for divide, but we have a few. We have per, quotient, and sometimes you hear this phrase goes into. That also might come up to play with divide. So hopefully you've learned a little bit about the order of operations, and this can help you when you're solving math problems.